This conference will now be recorded.
Okay, so again, thank you. Thank you to all who have joined us already. Get underway. My name is Noel. I do all the training and consulting work for Termite Australia, and I'll be presenting this session here for you today. Now, I live in Brisbane, Australia, on the east coast of Australia, just where Termite is based. I've been in the pest control and termite industry now for 20 years. I do have my own business here in Brisbane and do this as a consulting role for Termite. So you are getting information from someone that's using the device in the field and has done for many years. My first involvement with Termite products dates back about 16 years now. So I do have a pretty good handle on the situation. I do not know everything within the industry, but I know my way around termites and the Termite pretty well. So there will be time throughout the session for questions. I just ask that that we sort of hold off on your questions if something pops into your head. Otherwise, it kind of gets a bit out of hand with question after question. So I will open it up after certain times to questions. So if there's something you don't understand as I'm going along, please just jot that down for the moment. Or if a question comes into your head, jot it down. Then when we open it to questions, we can address those then. I appreciate we're all on a time frame here, so we'll try and get this completed as soon as possible. But we do have quite a bit of stuff to run through here for your benefit. So the object of today is to get a full understanding of the unit, where to use it, how it can be used, to advantage, limitations of the device, and so forth. So now I appreciate that construction is probably a little bit different from your country to mine, and the majority of scenarios and so forth, which I am talking about, do relate directly to my experiences in my country. Now I'm just going to mute everyone's microphones just to prevent background noise and other people talking over the presentation. So for the benefit of everyone, I'll mute everyone. But as I said, when we get to the point of questions, I will open it up. Certainly at that point, you can turn your microphone on and ask, or we can use the chat box that is available for use as well. All right, so we'll get underway. Okay, so I see going through the list of people attending that the majority of people do have the device or the availability of the device on here. So we do have a bit of a process for training. Normally, if you're a new user or a new recently purchased, you would have been sent a link which gives a basic rundown of the device, how to turn it on, and so forth. We prompt you to use it, garner any questions that you need answered. Come to one of these webinar sessions that we do, and then hopefully that fills in the blanks for you. From this, each of you that are attending today, if you are a user or an owner of the device, or you're within a company that does have one and you use it, a link will be forwarded for assessment questionnaire. It's from completion of that assessment questionnaire that you will then be issued with a certified user certificate. Okay, so as I said, for those of you that have been just joining, rolling in here, my name is Noel, and I'll be running the presentation for you today. Okay, so the Termite unit, the T3i, it is a 3-in-1 sensor unit. There are units that are available that do only have radar only, but we will cover all sensors throughout this session for everyone. Now there are some basics that I will be running through as well. So Any of you that have been using the device for some time will clearly understand what we'll be talking about and the basics of it. But it is for the benefit of everyone. We do have a wide range of users here, new and old, and yet to purchase. Okay, so the 3-in-1 sensor unit. We do have a radar sensor, which is a microwave emission device, and that's for picking up or detecting any movement within or beyond building materials. Now, as it is a microwave emission device, we do need to err on the side of caution. Do not hold it against your body or point it towards your face as such. It is fairly low emission microwave, but it is still microwave. So we do have to err on that side of caution. Thermal sensor. So thermal technology is becoming more widely used within our industry now for various reasons. The thermal sensor is detecting temperature differentials on the surface and on the surface only. And then moisture sensing, particularly with timber framed construction, with plasterboard and or timber packing, it is very important to be detecting or sensing for moisture issues, which not only can lead to mold, fungal decay, but also conducive to termites and other insects. All right, so in Australia, we operate as a guideline with documents called the Australian Standards. We have a series of inspections for termite and timber pest inspection. And recently it was updated 5 years ago now, and it's actually listed termite radar units should be used, or a competent inspector should have one at their availability. As under the specialist tools clause. However, as good as these tools are, we still need to conduct a standard inspection. We need to operate via our standard inspection procedures that we always do, and then we use the Termitrack, whichever sensor it may be, to our advantage for further investigation in a non-invasive manner. All right, so turning the unit on, and now, apologies, this is for the benefit of people that do not have the device or very rarely use it. Long-term users, you'll understand this, so just bear with me, please. It is for the benefit of everyone. So the unit is operated or powered by 5 AA rechargeable batteries, which 10 of are supplied within the kit. Once you install 5 batteries and correct polarity, the unit itself will run through a self-diagnostic process. You will notice at that point that the LED lights on the top of the unit will continually flicker and run through colour sequence. So that is checking for any internal componentry faults, and if no faults are detected, all lights will go out. Then we just need to turn it on, in which case a green light will be illuminated. If during that process the lights do not stop flickering and or flashing, or 2 solid lights stay on, that indicates that there is an issue with the device internally. We always recommend replacing the batteries with a new set or a close to fully charged set of batteries to rule out a low voltage scenario. Now, with the new set of batteries, if the lights all go out, that's good. The other batteries were either damaged in some way or low voltage, in which case can be charged up and you put to use again. However, if some lights do still stay on, it's at that point you need to contact Termitrack, and they will let you know what the issue is, depending on which post and which colour the lights are. As I say, once we do have it turned on, a green light will be on, With that green light on, we open the app screen on our Android device. We then hit the connect button. It'll automatically connect, excuse me, to the T3i. The green power light will change to a blue light, indicating Bluetooth connectivity. When we're using the device, another light will be on with each sensor. So when we're using the radar, we'll have a green and a blue. The moisture sensor will have 2 blue lights, and the thermal sensor will have a red and a blue. All right, so with the batteries, a few things which we do need to note here, which is important for them. Leaving batteries in the device certainly can damage the batteries that are in there, as there's some internal componentry which continually draws against the batteries, and at which point leaving them in certainly damages them and will not be able to be charged up. So when you're not using the device, always recommend removing at least one battery to break that circuit. However, my recommendation is remove every battery from the device, and that way you never forget that they have been left in. Also, then you can put them into your charging procedures. Leaving them in long term as well, and depending on where you are located and how you store your device, there is a chance of corrosion on terminals. Battery leakage as well may occur after long periods of time of inactivity. So for that reason, to prevent any damage, remove batteries entirely. Now there is a battery voltage indicator on the app screen, on the home screen. You'll note below the moisture icon, which is a little raindrop, and above the disconnect button, you'll see that green there. That is the charge of the batteries installed in the unit. Fully charged is green. Graduations disappear as we use them. And then when it changes to yellow, that is the time we need to change the batteries over to a new set of batteries. All right, so with the batteries as well, as I said, you will be supplied 10 in your kit, and all batteries will look the same. So it's suggested here to mark 5 batteries. Put X's, dots, number them. So that way then you have 2 sets of 5 batteries. You're always using the same 5 batteries in the unit together and charging, depleting at the same rate. That will extend the life span of the batteries and certainly help you out through the day of using it. If you're in a company where you are sharing a unit, so there's multiple technicians using the one unit, everyone needs to understand the maintenance of the device. So by removing batteries, whose responsibility to charge them, and so forth. So however you set that up within your company to make that easier for everyone else is entirely up to you. It can be as simple as writing on the battery cover or putting a check note inside the storage box to let you know your users how to keep it maintained. So the radar sensor, I mentioned earlier, it's a microwave emission device, and we need to err on the side of caution with that. Now, the advantages of that radar sensor is it is a highly accurate tool. So it is going to aid in confirmation of termites or other moving insects, depending on what we're doing at the moment. Confirming the activity or the extent of activity, or proving or disproving there is any activity in an area. So termite management, first rule is least disturbance as possible. for those termites. So if we do see a damaged area within the structure, we suspect it's termites. Do not go opening it, pulling it apart, because if there is active termites in there, we do run the risk of them vacating the area, which then hinders our treatment procedures. So being able to use the radar to confirm that in damaged areas, and then we can say it's either a active or a non-active site with the termite damage. Non-invasive, we're not having to drill holes or cut out wall sheeting as such to be able to use the device. However, it does not remove the need to do that 100% of the time. There are times where we just need to open it up and put our eyes onto what's within the voids or beyond material. However, it is a very good non-invasive tool as a first step. Tracking termites. Very important to be able to track them within the structure to find the full extent of their activity. The more activity you find, the more treatment options become available to you. Being able to track termite activity, hopefully back to an entrance point, which may be concealed. Getting close to that entrance point obviously then allows us to put a plan into action as far as preventing future colony ingress. And precise treatment. We do have a lot of products available for treatment. Obviously, with each product we're using, we're trying to achieve the same outcome, and that we should be looking at achieving colony elimination, if not colony disruption. So numbers are everything. Termites. The more termites that become in contact with our treatment product or products, the more chance or the better chance that we do have of elimination. So the precise treatment, placement and tracking of termites with the device goes hand in hand in that sense. Putting the products where they need to be is always going to work better than guessing where to put the product. It will also save us follow-up procedures, utilizing our marks from tracking prior to treatment time, and then we can confirm whether the activity is still present or not. So the positioning of the radar. It is always better to have that radar face sitting flush on the material we are trying to use it upon. If we have an air gap between the head of the unit and the material, we can experience what's known as microwave reflection. The more smooth, more glossy material, the more reflection we will experience. So try to have it flush wherever possible. There are some instances, however, even having it flush then can create some issues. The most material that we have issues with are tiles, marble and granite, or even high gloss paints can create an issue. What happens is a phenomenon known as emission spill, where the unit is flush on the material, but due to the smooth, glossy nature of the material, the microwaves are squeezed between the unit and that material and emits sideways along the surface of the material. So if there's any movement near that on the external side of the surface, it can register and we can have some issues in deciphering what's going on. So in that instance, I always suggest putting a piece of cardboard between the device and the material, and that can dampen any of that emission sideways spill that we do experience in those scenarios. Now, there are times when we have to use the unit and the head is not flush on the material, i.e. if we're using the built-in flip stand, for example. We can still do it, but we must be mindful of the reflection. So anywhere where we aren't flush, utilize the Bluetooth of the Android to the T3i, position your device and move well away from it. That way you cannot influence anything via reflection, which may give us a pattern on our Android. All right, so building materials. Now, obviously, these building materials are very, very common that we come across in Australia. May or may not be so common in your part of the world. But all these products we do see here on the screen, it will penetrate to certain depths and degrees. As the building materials increases density, the penetration ability of the device does reduce. So looking at these products here, bricks and concrete blocks, it'll certainly penetrate. It will go through a standard clay brick through sideways, and concrete blocks, it will get into the internal core. If it is a core filled block, it will not go all the way through. It will not make it that far. However, we can utilize the device to track between the mortar joins or any cracking. Tiles, marble and granite type materials are very porous, and the unit does penetrate those quite successfully. However, we do need to be mindful of that glossy finish. Particle boards, so press board, chipboard, MDF, and the like formed boards. It will penetrate through those, no issues that we have come across. Plasterboard, yes, it'll certainly go through that. With timbers, the biggest thing that affects penetration is the density and thickness of timbers. So obviously softwoods, it will penetrate more successfully and deeper within that type of material. So to give you an indication on depth penetration, test concluded with framing timber, which was a pine, so a softwood, with plasterboard on it, we're achieving between 80 and 85 millimeters of depth penetration with an adequate reading on the screen of our Android. As we increased into more dense material, hardwood types, the penetration does reduce quite significantly, and it will almost halve that of a pine product or a softwood product. So in tests we did here with some native hardwood slabs, we're only achieving around the 40 to 45 millimeter mark of penetration. So it's about understanding what penetration abilities we can achieve, and then it's working around that, reposition it, go from a side, above or below as needed or able to. Now, if we look at the bottom face of the T3i unit there in that picture, you'll notice that red square. Within that red square, you'll notice there's a circular area with little outwardly laid indents. That is the size of the field of view. So it is roughly 35 millimeters by 35 millimeters. So it isn't all that large of an area. So positioning is everything. And the emission comes out in a square fashion. The reason being is when we have the unit placed on material, we want to know if we're detecting movement, where that movement is. Having it leave in a square fashion, we know it's directly under the head of the unit. So sometimes we need to move the device around in various spots to be able to find the sweet spot, if you will. Don't just place it in one position and we're not registering anything, and then you feel the device isn't working. Sometimes moving at 5 millimeters or so, one side or the other, certainly can help. Now you'll notice in the top picture there is a flip stand on the device. That helps for positioning along against walls and the like. So that way it's just changing the angle of the device, so that way we can get into the bottom of corners, timber bottom plates, skirting boards and such. So there's two limitations to the radar and a microwave technology. The first limitation is microwaves cannot penetrate metallic objects. It will bounce off that metallic object, but cannot go through it. So if you do have a position in this country, the biggest issue that we find is on timber frame homes, they do have a product called sisolation, which is a foil wrap which goes on the external side of the framing timbers. Now that is a condensation vapor barrier. So if we're sitting on the internal lining, pointing straight outwards towards the external, and there is no movement directly below it. However, the microwaves will hit the metal, bounce off, and we can get all sorts of funny patterns on our Android screen diagram. However, if we do have metal beneath, directly beneath a penetrable object like plasterboard or a timber panel as such, due to there being no gap between the device and the metal, in that instance, we won't get any reading at all. So it's very important to understand the construction, in particular the construction of the building that you are in and using it. The other limitation we do have to the microwave technology is moisture. So moisture essentially will absorb the microwave energy, which what that will do is reduce the signal that we're getting on our Android. When we obtain an area which has 25% indicative moisture or more, we will be achieving total absorption rate, and we may not get a reading at all. However, we can work around that by using the moisture sensor to pinpoint the exact extremities of that moisture area. And then we can use the radar device to check for any activity traveling to or from that moisture area. So again, it's about understanding what these limitations are and how to work around them. So the screen that we do have on our radar sensor, what we see is broken into two parts. We have the radar, and then we have shake. Shake is an accelerometer, so that will indicate if there is movement or excess movement of the device itself. And you will get some sort of pattern in the grid box and a blue flash from the bar graph below it. We do not want that in there when we're using it. If we do get any signal in that section, in the shake section, we cannot rely on the results that we're getting in the radar section above. So we do only want to get patterns or the sine wave in the grid box for the radar area, and that's the last 10 seconds of interval. So end to end of that box is 10 seconds. So each grid on that picture is a 2-second interval. It travels from the right side of the box to the left. Directly beneath that grid pattern for radar, we have the instantaneous blue flash. So what will happen there? As movement travels through, it detects the motion, you'll get an immediate blue flash response. And then we look up a pattern traveling from the right to the left, and that is where we need to interpret the data for what insect or creature it is moving. There is a gain level function on the device that goes from 1 to 10. It is a volume button of sorts. I do recommend starting on gain level 5 or 6. Generally speaking, we're using it on 6 predominantly, and then we need to adjust that gain as needed. As we go up in the gain level, it does become more sensitive to movement, excess movement of the device itself. What we have found, anything above gain level 8 can be problematic when trying to hold it with your hands. So utilizing other tools or equipment to keep that unit steady where it needs to be, what we have to do there. So these three diagrams are showing gain levels 3, 6, and 9. If you look at the radar screen, you'll notice in the grid box that the patterns are getting larger. The idea is not to have it too small or not to have it too large. Too small or too large makes it difficult to identify or interpret the data presented to us. Everybody is different on the sizing they need for interpretation. So it's a situational basis. You may need to lower it, you may need to increase it. You may need to continue to do that throughout your procedures of what you are doing. That is purely related to how far away the activity is from the unit, i.e. you need to penetrate more material before where the termites are. You need to increase it. The termites are closer to it, the surface within the material, you may need to decrease that gain function. So this little video here will just show you in real time what's happening when we adjust the gain function. So a test bit of timber, to the left of the screen of that we have some artificial movement. That artificial movement is saying the same distance from the test timber and also moving at a steady pace. So then we'll look at what happens on the screen when the gain is being adjusted. You'll see there it was quite large, now turning it down. So again, there is no set number to be on. It is per situational base and per individual user as to where you are more comfortable to be able to identify the data correctly. So it's not increasing the output. Think of it as a zoom function or a volume control. So some items that may assist in positioning of the device. Tripods are available, which do extend to roughly 3 meters in height. That is advantageous in certain areas, may prevent you having to utilize a ladder to get to the height you need to be. The monopod is in the middle picture and bottom left picture. That is an extension tool or a reach tool. So if there's an area where you can't physically crawl to or fit your arm in physically, you can use the extension of the monopod, which does extend about 1.2 meters, which may enable you to get the device where it needs to be, even though you can't physically reach there. The monopod being used on a wall, there is some stability feet available for use as well. The flip stand, as I mentioned earlier, you can see there how it would change the angles and enable you to get to the corners of a building wall floor junction as such. But use anything available, boxes, books, a desk, a chair, whatever it may be to get it to where it needs to be. Okay, so talking about patterns, all it is data we're being given here. So we need to interpret that data successfully to work out what is actually making that movement. So reflection from metal, our hands ourselves slightly vibrating. Vibration in the material that we are positioned against. So if there's a mechanical object nearby creating a vibration or a harmonic situation, that can give a signal into the unit. However, if it's a light vibration, you may not have anything in the shape section. It may only be in the radar section, but not necessarily indicating movement. So we need to rule that out as well, and I'll explain a few tricks about how we can do that. Now, the data we're looking at here, termites are quite unique in the sense that through the different genus and or family level and certainly species level, termites are very, very similar across the board. The way they're built, the way they physically walk and move, very, very similar. Yes, there are some differences amongst them, obviously, hence we have so many worldwide. However, the basis of them are very, very similar across the board. They all walk in a very similar fashion. They tend to be touchy-feely creatures, so either walking side by side or nose to tail in an elephant-type trail, if you will. So with all those commonalities with termites, we've just started to notice that there is some consistencies and similarities within the patterns, which do make it easier for identification. Now it comes down to, with the patterns, what I'm looking for is a consistency within the pattern itself. Now looking at these patterns, they may look quite inconsistent, but if we break them down into two parts at a time, we can start to see that consistency. Now the two parts I'm referring to here are the valleys. So if we think of the low port where it's going down, and then it starts going upward, and we refer to that as the peak. As we move cast our eye left to right, the valley comes first, and then the following peak joins with it. And if you notice there, joining those up, you'll notice that the valley and then the following peak are almost identical in shape. The termite pattern as well, you'll note there on the peaks and the valleys, they're not perfectly pointed. They have little step downs in them. We have noticed that to be very common with termites themselves. So that's another little cue to be looking for. But determining the valley and the following peak, which are very, very similar patterns, that is a very strong indicator to having termite activity. So if we look at that going across, you can see if we group them into twos, how similar they are. Whilst each second one isn't exactly the same, it's the valley to the peak that we're looking at. The slight variation then that we get from the next one, that may mean different numbers were in the field of view at the same time. So that's why we're getting slight variances, but the basis of what we're looking at is very similar all the way across. Now you may notice there is some spiky parts within that pattern, particularly on the left in the Coptotermes pattern. So the first lot of spikes are in 1, 2, and 3 grid from the left, and then we look over to the second grid from the right. So what they are, those areas there, that's indicating that there's more termite activity in the field of view at that particular moment. So what happens is there is absorption into the creatures naturally with the microwaves, very soft exoskeleton termites. The more termites that are there, the more absorption actually happens. And then when there's a slight break in the motion, we're getting a release of energy, which then leads to the spike that we're viewing there. So the more absorption, the larger the spike will be. And that's a very good indication that there's a lot more numbers in that area at the time. So those cues can lead us into the determination of aggregation areas, feeding areas, or possibly even getting towards entrance points as such. So everything within that pattern can start to tell us a little picture or a story. Now, there is another thing which I do when I'm utilizing the device to make my final determination, and that is manipulating the data. So I'm actually manipulating the termites by way of excess vibration or tapping along the material where I believe them to be. that will trigger a response from the termites. It's a natural response to termites. It's part of their defense mechanisms. So termites are a very soft-footed creature. Part of the reason they are a soft-footed creature is so they can pick up on any vibrations or cues, which then they can identify as being too heavy for their colony members or within their working area, which can also indicate to them that it may be predatorial ants, for example, trying to break in. It could mean they've eaten too much of the timber and it's starting to creak and groan and risk collapse. So by tapping around the area, it will trigger a response. Soldiers' case will start tapping their heads, vibrating bodies, and the like. What this does is marshals more soldier termites to that region, and it may prevent the workers going to that area, depending on what they believe the problem may be. So what we see after doing that tap, we do see an increase in activity as presented to us via the patterns. The patterns will become more intense as such. Then after a moment, the termites will realise that it was a false alarm, and they will come back into their normal formation and continue on. So after tapping, if we do see that considerable change in the pattern, it's a fairly good indicator that it actually is termites. Now, that is very common across all termites. And all termites will react in that sense. So it is a good thing to do, and it's a good way to rule in whether it is termites or not. Once we determine that it is termites, then we can move on and do our next procedures. Now, I do get a lot of questions here about ant patterns and the like. Now, ant patterns are considerably different to termites, more so in the regular pattern as we're looking at. They're very more triangular or pointed shaped tops and bases, and the valley to the prominent peak generally have some quite considerable variances involved. So they are not as uniform or consistent as the termite pattern. A lot of that is due to the ants having a hard exoskeleton, so there is more reflection. Also, ants tend not to be bothered by outside influence. So if you're tapping around an area, ants will continue on doing what they're doing. Unless you adjust the atmospheric pressure within the working area of the ants, they may not react at all. So that's another good way of ruling termites in or out, also along with other insects. The tapping technique to see for changes in the patterns also helps us to alleviate any mechanical vibration which we may be experiencing, on our patterns. So if it is mechanical vibration, example, an air conditioner attached to a wall that we're testing, when we tap on the wall, that pattern won't change because it's a mechanical object. So if that is the case, what you need to do is you need to turn off the device or the mechanical device that is creating that problem. Obviously, let your client know if it's an air conditioner or a fan or a fridge motor that you need to rule out from the situation. So it is something with the interpretation that it does take time. It does take use of the unit itself in varying situations. And then it becomes a lot easier to identify what we're actually looking at in that particular area. It can be done, but it's just a matter of understanding the little subtleties that I've just been explaining. Now, if we move to the pattern to the right, which is it's a drywood termite, a Cryptotermite brevis. Now, there are many drywood termites around the world. Now they're a little bit different to subterraneans, obviously, in the sense of they do not use fecal matter and dirt and entering or introducing their own dirt for their mudding and so forth. They have pellets, so they're an open gallery. They're a very slow-moving creature. I call them the lazy termites, if you will. So they do sort of just plod along quietly. So the patterns themselves in smaller colonies numbers, the patterns themselves are a little bit shorter than subterraneans, purely due to less absorption rate and then less releasing as well of that microwave energy. So they're a little bit smaller. They also certainly do react to the outside influence of scratching above their working area or light tapping, and it will garnish a response from them as well. So again, whilst the pattern on the right to the left do look different, if we break down that pattern on the right, we can start seeing the similarities and the consistency between the valleys and then the peaks. So whilst they are very, very similar across the board, there are slight differences. And a lot of that has to do as well with numbers of the colony, the type of area within the structure where they are infesting at that moment. But the basis of that pattern will be very, very similar across the board. So time, use it, practice it, different scenarios, the better you will become at identification. All right, so I'll just run this little video for you. It does indicate a few things here, how to hold it, tracking, marking, so forth. So I'll just run this one for you now. Okay, so now we're back into a different section of the home. Now, I highlighted this area this morning. It actually was highlighted this area by a very clever little dog. So I've come back to this area with the radar first up. Now you can see I've got marks looking up here. So I spent a little time this morning. All these marks have indicated activity. So there's a double stud in here behind the door frame. So I've indicated that. Now if we look at the pattern here, there's a lot more intensity than what we were actually getting previously in that other section where the moisture. Now I'm just going to move it up a couple of these other marks, which I knew I had this morning. I'll come up a bit higher here. I'll put on the same mark. And I'll just hold that there nice and steady. I'll stop talking for the moment and we'll look at the pattern. So that instance, we need to turn that pattern down. I'll drop that down to 6 even. Very healthy. But what I'm going to do now, I'm just going to move it sideways off that area. So you see now what's happening is that's going down to a flat line. The reason I've done that is to rule out if there's any shaking with me, creating vibration to give us a pattern. And there's a little bit there now for me talking. If I'm not talking, you'll see that's coming back flat. I go back to our mark. And there we go, getting that heavy intensity again. All right, so hopefully that's a brief explanation for you and you understand exactly what we're trying to do with moisture areas, then checking in for termite activity leading to moisture, but also our series of marks. So each of these marks is stepping stones, and that's showing me we go all the way up here. I've got up to this point here. Now there is another room adjacent to this entrance where we are getting activity, quite heavy activity. So what I'm going to try to do now is work out where have they entered the structure. Once I've done this process, then we'll work out the best way to treat it. All right, okay, it's next time. Have a good day, everyone. Okay, so hopefully you saw a few little tips there that can be useful in using the device, particularly the one if you're holding it or when you're holding it, don't talk. Remove any chance of you giving any vibration into it, but also if you feel it's yourself vibrating, just move it to a random position and see if you're getting a different pattern, if you will. If it does go steady, obviously what's going to happen there is where you were, it probably did have the motion actually there. Okay, so that's the radar section. So that's probably the most involved that we're talking about today. Is there any questions relating to the radar?
See, my
Feel free.
request is, this is Nitin Jagtap. My request is, whenever you are planning for this type of webinars, for India, can you start in Indian time 9:30, because 8:30 our offices are opening. So people are traveling or they have to give the job schedules to the technicians and all. So everyone can't join at 8:30. If you can schedule it at 9:30, that will be a better for us.
Okay, that's duly noted. I'll pass that on to the office. Okay, so do we have any other questions in relation to the radar or what we've spoken about so far?
It was explained thoroughly. I don't think anyone has the questions.
I'm sorry, I missed that.
Uh, you have explained very thoroughly. So every point has been explained clearly. I don't think they will have any questions. They are already
Excellent.
using this Termitract in their offices.
Fantastic. That's great. All right, thank you for that. All right, so we'll move forward. We'll move on to the next sensor to talk about. So the next sensor which we'll run through here is moisture sensor. Okay, so obviously again, timber framed homes, plasterboard line and the like, or timber cladding, very important to be checking for moisture issues, water leaks or otherwise within the buildings. Obviously excess moisture for prolonged periods of time can lead to mold or fungal decay, which is highly conducive to termites. Moisture itself is the attractant to termites, and then from that attractiveness, then generally they will be foraging closer to where there may be timber products. So having a good tool, an accurate tool to be able to test for moisture is paramount to a quality inspection. The Termitract does offer that within its own moisture sensor here. So it is a dual mode moisture sensor. It has a direct function, which displays any movement, increase or decrease in moisture values, and it displays them to us in a percentage. The relative moisture mode, we're not looking at percentages at that point in time. All we're doing there is looking for vast differences between areas. So to get into or open it, we hit the raindrop, and it will open up the device. The actual sensor itself, you'll note there on the picture, the back face, upright face, there is a black ring. It's within the unit inside that black ring. It's not the black ring itself. That black ring is just there, as then when we are placing it on the material or the surface of the material, what it's doing is preventing any ambient air coming in sideways to it. So direct mode, it's giving us a percentage display, which is an indicative percentage of moisture content. Generally speaking, we're using that on timber products in that sense. We can have alarms set up. There's 3 stages of alarms. Now, those stages of alarms are individually set. So it's for you to set up with your understanding of what the equilibrium moisture content values are within your region. Also depends upon how much rain we have or ambient humidity, so forth. So that will continually change. Very easy to do. 3 little dots above the white screen opens the options We turn on the alerts via the checkbox, and then we adjust those 3 numbers that we have for low, medium, and high settings. And that is whatever you determine to be an issue with moisture. Changing over to the relative mode, beneath the white box, you'll notice there's a word direct moisture on or off button. So we turn the direct moisture off, and then we're open to the relative. Now, the relative sensor is good to be using on items such as concrete, brick, masonry, that type of scenario. Non-invasive direct meters are not accurate on those type of materials or substrate. So at this point, we can use the relative, where we set a reference point on the material initially, and then as we move it, it will tell us whether we have a difference in moisture content or not. We have a large enough difference in moisture that certainly can warrant further investigation. So on the screen, you'll notice a bar graph. We reference it by tapping anywhere in the white box. And then as we move it, we move to higher moisture, blue will come out. We move to lower moisture, red will come out. So as we open the device, it'll run through a self-calibration. So that's taking into account the ambient humidity and moisture values. So it does make certain internal changes to its parameters depending upon the moisture that's detected in the air. Now, at this point in time, during the calibration process, you cannot be holding the device near the sensor area, or you cannot have the sensor area resting on material, in which case it'll detect an interference, it'll sound an alarm, and you will not be able to use it. So you need to exit it and then reopen, reposition it and reopen it, and then it'll work for you. Now, I'm not sure what type of meters that moisture sensors you currently have available to you where you are, but in Australia and quite other places around the world, a Termite moisture meter is very, very common. So I do a direct comparison to those. As we can see here with these pictures, the Termite is the lower one, the Termite is the upper one. Now, the meters do come into the same group of test equipment, which is known as a non-invasive dielectric moisture meter. Non-invasive, it just sits on the surface of the material. Dielectric is telling us that there is an electrical current that's emitted from the device, and it's from that electrical current through impedance, resistance, and such that makes the needles move. Now, the Termite unit itself operates on an arc of conductivity, so it has 2 pads. So it transmits electrical conductivity through the material, through the receiver pad. It's from the differences in resistance values on those 2 pads as to where the needle will sit. The Termite, however, operates a little bit differently. It operates on a capacitance-based conductance, so it is continually discharging and re-energizing. So it takes its readings a little bit different. It goes on speed of between full discharge to re-energization, including certain levels of impedance, which will then make the needle move to give us an indicative reading of moisture. It does penetrate quite successfully into timber products, up to 60 millimeters in a softwood scenario. Termites do only penetrate roughly 19 millimeters on average. So there is quite a difference in penetrative abilities between these 2 items. Now, all non-invasive meters that fall in this category, the dielectric category, we're not actually relaying the moisture content. They are actually detecting changes in density of the material, which then the units are set up internally with their componentry to move the needle to give us an indicative percentage of that moisture content. So it's not water itself we're actually measuring. We're measuring the density changes, which can indicate that there is a moisture situation in there. So we do need to understand that. Being a dielectric style meters, they will detect metal. So if you do run across metal beneath the surface, it will react and it will give you a high reading. So again, knowing your construction of the building that you are doing your inspection in at that point in time is highly advantageous. So if you do get elevated moisture indication, is it elevated moisture, or are you picking up on something metallic beneath the material itself? So I'll just run this little video here as a promotional video Termite did a few years ago, but it gives you a good indication on how the units can be used. All right, so you probably see there that the use of the monopod whilst doing moisture sensing there, that enables for good body position, not having to bend down or overstretch and stuff, so you can remain in an upright position. The Termite can be slid across materials and it's an instantaneous reading, so that does make it quite easy for use as well. So the advantage of the direct moisture meter. Now again, it is more designed for using on wood, plasterboard type products as opposed to masonry and concrete. That's where we'd use the relative meter. So it does identify differences in the moisture in those materials. It's designed to work accurately and measure within high humidity areas. And that's purely due to the self-calibration of the device. Penetration through timber products, as I said earlier, up to 60 millimeters on average. And slidable, as I said, attaching to a monopod to keep your position correct in an upright. So it does come into a health and safety scenario there, where it can reduce stress on our bodies. And then also the alarms. So three sections, three different pitch for the alarm tone. All right, so the relative meter. So we turn it off on the screen. On the below the screen where it says direct moisture meter on or off. So we can turn that off quite easily, and we're onto the relative meter. The relative meter, what we do need to do is place it on the material in question. We tap in anywhere on the white box on the screen of our Android that has referenced it. So it's a 0 point or a start point. When we slide it away from that referenced area, it will detect any movement or changes in moisture. If blue comes out, we've moved to an area of increased moisture. Reds come out, we've moved to less moisture. Now there is a gain function on here as well. Now it usually will be set from factory on 3 or 4. We don't need to continually change it like we do with the radar. It is adjusted for sensitivity that we're getting on our screen, so it's governing how much red or blue will actually come out. Because we want to see peak values, don't move it realistically above 3 or 4, because then you do run the risk of changing or filling the box with the red or blue, and then we will not see the peak values. When we're using the relative, we want to know where is the maximum area of it. So having the gain setting a little bit lower is always better. So penetration is the same as the direct function, up to 60 millimeters. And it's instant reading. Refresh rate is instant. So we will see those changes happen as we slide it across the material. Okay, so I have a couple of little videos here to show. Now what these videos are going to depict here is coupling the moisture sensor use in with the radar itself, and it also shows us the procedures to get around the scenario of high moisture where we can't use the radar directly on that area. So being able to utilize it, sensor, we pinpoint the extremities and then we can use the radar. So these little videos will show you the exact procedures and how to use it. We'll just run those now for you. So first thing we're going to do is double check our moisture area. Radar doesn't work on high moisture because it gets absorbed. So we need to highlight and pinpoint the extremities of that moisture so we use the radar. So we'll just go ahead and do that now. So what we're going to do is just show you here when we turn on the moisture sensor what happens. And this is an important thing to do. Always stand the unit up. Sensor area needs to be open. So as we open the moisture here, you'll see what it's doing is running through its calibration process. It is a bit of a humid day today. There's some rain around. So what's happening is it's going to factor that into the equation. So now we're open. So I'm just going to run it across the wall over here, and we'll see what sort of figures we're getting. So just down low. So that's not an unusual sort of a figure for where I'm located and time of year. Now we're starting to climb up. All I'm going to do is just roughly in this area where it is all the tree, just got a general, just a little pencil mark on the wall. So I'm still going along. So that's elevated moisture. Now we're just starting to break off. So just generally speaking, close area, just another pencil mark. So what we have to do now, we need to flick over to the relative meter. So to do that, direct moisture on off. We're now on relative. So this is what we're going to use to pinpoint the extremities of the moist area. So all I'm going to do is roughly go back to the center of my wall where I had that moisture. I will now hold that on the wall. Over on anywhere in this white box, I've now referenced it to that wall area's moisture, my moisture, humidity of the day, and so forth. So now I'm just sliding along the wall. You can see now red's come out, red's peaked. So that's telling me I'm to the least amount of moisture along this area in comparison to where I referenced it. So now I'm just going to come back, sliding back towards where I referenced it. Now just on the screen there, we see that red's just disappeared. That now has become the exact extremities of the moisture. I'm going to use that central to where my sensor is and mark the wall. So over on the wall here, you can just see this mark here. That was our extremities this way. This mark here is our height. So along here, roughly this height slightly changes. The extremities here, it is quite high now. That is above the bottom plate. So it is indicating that there is quite a bit of moisture. More than likely, it's due to the ensuite shower that is leaking. But we're going to investigate, because as we know, moisture is highly conducive to termites. They generally won't be in that high amount of moisture. However, they will come towards it as a condition and usually on the fringes. So what we've got to do now, we need to get on the radar and check for any action, motion traveling to and for that area. Okay, so that was showing you there exactly how to open the device up, which buttons to press and so forth. And a good indication on what to do or an area on how to do it if you do detect moisture in a particular area. So very simple to do, non-invasive. A few marks on the wall, use check or a light pencil, chalk or a light pencil mark on the area so it can easily be removed. And you don't generally need to ask permission to your clients. to go ahead and do that procedure. So I'll just run the follow-up video to this one. Okay, so Noel here again. This is our wall where we checked out the extremities of the moisture, these marks. So what I want to do now is put the radar here. I want to check along this area to see if we're getting any activity of termites travelling towards this moisture source. As we know, it's very, very common to exploit that. So you see here, that's my extremities. So I'm just going to start over to the edge. I'm going to run it on the flip stand. So at that angle, what I'm doing with the emission, the motion, that's going to get down to the leading edge of the bottom plate, sort of down to the bottom. So just let that sit there. I'll move back. And it's showing a little bit of a pattern. What I'm going to do now, you'll hear this. So you'll see this intensified from me tapping. And we'll sit back and we'll watch what happens to our pattern. So what's happened, you'll see from where me hitting it, it's disappeared. Now the pattern has changed a little bit to when we initially put it there. So that's a good indicator. Termites are there. So what I'm going to do, this position, just pencil. That's indicating I'm on the 45. So now I'll just move it along random areas, okay, but on along the same plane. So we'll just move the screen up a bit closer. So I have gone about 12 inches or so here. Make sure we're all still. Again, I'm getting a little bit of a pattern. So I'll give them a bit of a... So that was me. Now here, you can see those termites, or the movement has certainly intensified that wee bit. Very strong indicator of termites again, going through there. So I'll just do one more spot. Oh, I better mark that, sorry. Just faint pencil. Come back along here, same sort of distance again. And that's indicating, so it's worth investigating a bit further. I'll come right back down to the corner. We'll see here actually now in this corner, that pattern is a lot more. So that is, again, a very good indicator. They're travelling along the external wall, and then they've highlighted this moisture zone, and they're probably coming in, travelling in on small numbers to start with, to investigate. Okay, so you can see there it's quite a simple process to couple in the moisture sensor with the radar if you do suspect something's going on within a structure. Again, it doesn't take long to be able to do that, and you certainly don't need to ask permission. Okay, so any questions relating from the use of the moisture sensor? Okay. All right. So we will move forward and go on to our third sensor. Okay, so the thermal sensor is the final sensor on the Termite unit that we will discuss here. So thermal technology is becoming more widely used within our industry. There's a few misconceptions about thermal technology. One of those is that people seem to think it is X-ray vision, and it's not. Thermal technology, it only measures 1/1000th of an inch of the surface material. So it is no penetration at all on solids or liquids with thermal technology. It is not X-ray vision. It cannot see through walls. It is only picking up surface temperature differentials. We are not looking for heat. We are not looking for hot spots. We are looking for thermal differentials. So there's a big difference in using that terminology as to the outcome of the device as well. So the technology on the thermal sensor with the Termitrac is the same technology used in thermal imaging cameras. However, it displays the results differently to us on the Termitrac. So with the Termitrac unit, we do not have a thermogram on a screen. You'll note the screen on Android now is not a thermogram. It's very similar to what we're looking at on the relative moisture sensor. So essentially, it is a relative thermal sensor as well. The bar graph, what we have, we reference it, point at the wall. There is a laser point which comes out, so that depicts the area of the material we will be testing and starting our reference point from. Tap in the box, zeroes it. As we move it along the material, if red comes out, it indicates that we've moved to a surface with higher temperature. And then we have the numerals telling us what the change is by how much it has increased temperature. If we move it and blue comes out on the bar from the right-hand side, it's indicating we've moved to an area with lower moisture content, lower surface temperature. And then it's depicted with a negative numeral on the top of the screen there as well. So very easy to see, very easy to read the results, very easy to use. However, we do need to utilize the reference each and every time. If you're changing material or changing building, changing the orientation, i.e. going northern wall, southern wall, internal wall, external wall, for example, you need to continually reference it to that particular region. So the thermal data that's presented to us, as I said, a thermal imaging camera runs a thermogram on it. And there's a lot of information on thermograms. So whilst, yes, they do look good, do we have the knowledge to fully understand it? Obviously, doing a registered thermography course can indicate to us exactly what is going on, do's and don'ts of it. So there is a lot happening, and if you're not fully trained on it, there can be some pitfalls that we come across. So in this case, a picture can certainly tell us 1,000 words. However, with the Termitrac only telling us the difference in temperature by a numerical fashion, that leaves no room for misinterpretation at all. So you don't need any extra qualifications to legally be able to use it and comment on it. And it is very, very easy to use, read, and understand. So the same as the thermal image camera, it does have an optimum distance, which is governed by distance to spot. What the distance to spot's actually doing for us is altering the size of the instantaneous field of view. Further away from the material you go, the larger surface area it is actually taking its readings from. The Termitrac operates on a 12:1 ratio. So basically with that, if you are 12 centimeters from the material, it will read a 1 centimeter diameter area. Further back you go, the larger that area will become. Optimal use of it, you realistically want to be within a meter. The larger you go, you can get to too large of an area that you're trying to test. And because the surface temperature is averaged within the region, going too large can actually defeat what we're trying to achieve by averaging in the problem which may be present, but we may not see it with a too large of an area. Now, once we do reference it and our set distance, whatever that may be at the time, you need to remain at that distance when you move it. So what that means is, if I'm at 1/2 meter standing at one end of the wall, I'm 1/2 meter from the material, I reference it at that, I can't just stand there and then scan it down the wall because the distance to spot is increasing. So that is increasing the surface area which we are testing. So that will change the results immediately. So having to move parallel, so vertically, horizontally, diagonally, it does not matter, but we must remain at the same distance that we were when we referenced it. Now that is no different to a thermal image camera. They're designed to be worked in the same manner. Must be used parallel, and each camera has its own specification as to the optimum distance to be used from the wall. It'll also indicate the specifications of cameras on how fast we should be moving as well. And there are a lot of settings within thermal imaging cameras that can be adjusted depending on the model of camera that you may or may not have. And again, this is where thermography training comes in play for learning on which way to have those settings set up. Now there is a gain setting on the thermal sensor here. The gain setting again is just adjusting the sensitivity by way of adjusting the surface area range. So the higher setting we go, the lower the surface area range becomes. The lower the gain level, the higher the surface area range becomes as well. Essentially, it does not matter where you have that set up because we're getting given the numerals on what the exact change is anyway. So that's going to tell us what's going on. The blue or the red coming out is more. However, the factory does have it set. It's generally on gain level 7 or 8, and you don't really need to move it. You certainly do not need to move it up or down like we do with the radar in there. So there are many places where it can be utilised. On it, again, we do need to understand a few things. Always reference it, different material, different location, re-referencing, and remaining parallel at the same distance from reference points. Obviously, for safety reasons, with the laser pointer, do not point that in anyone's face or look into it yourself. All right, so that is the thermal sensor. There's not a lot in the thermal sensor on it because it is quite a basic setup there for us, which does make it quite easy to utilise. The big advantage of TermTrack is that we do have the other sensors that we can use, one or more sensor in a particular area to give us the results or information that we desire. Any questions on that? No? Okay.
For tracking the termite trails, it is very difficult. We want a lot of experience to track the trail of the termites. If they are in the walls and wooden walls, and they are again traveling from the flooring. So in flooring, this termite track don't detect the termites.
In what type of flooring?
Tiles. It is a vitrified tiles, glazed or vitrified tiles or marble.
Marble flooring.
Yeah.
Yeah, so you're talking the termites below that marble flooring.
Yeah, they are traveling below the marble flooring. There is a concrete slab, and on that there is a sand, and above that marble is there. In that sand they are traveling, but we are unable to track that termites in the marble flooring.
Okay, so it depends on how thick that marble material is.
Okay. Okay.
So what sort of thickness are you talking?
It may be 1 inch thick marble.
Okay, so look, we have done tests on marble, and it certainly did penetrate that sort of thickness at all. I mean, it possibly could be depending on the numbers of termites. So let me just get this right. You have a concrete slab, and then there's
Yes.
sand, and then there's the marble laid on top
Wow.
of the sand.
Yeah.
Yeah. So you're quite often finding termites running between the concrete and the marble. Is that correct?
Yes, correct, right.
Okay. So where are the termites coming up through the marble?
They are traveling from the external wall and coming in the flooring in the marble.
Yeah.
And they are
And then
again traveling through in the flooring and coming on the internal walls wherever wooden paneling is there on the walls.
okay. Okay. So in that sense, and obviously it's problematic to treat below the marble. Is that the situation here? You can't drill the marble or put a treatment product into that soil. Is that right?
Yes, right. We are unable to drill the marble.
Yeah. Okay. So I mean, in that scenario, if they're in those timber areas, yes, depending on numbers traveling through that soil or what type of moisture content, that can be an issue with tracking below there, and that wouldn't matter what substrate it is, whether it's or what flooring. If there is too much moisture or the sheer volume of termites are there, yes, that can be difficult. But in that sense, if you have them then in a timber product or a timber frame wall, for example, internally,
Hmm.
being
Yes,
able to track them within that wall to find suitable areas to put the treatment product or a bait station on that, do we really have a need to know exactly where they are underneath the marble at that point? Because if you can't drill
Hmm.
underneath the marble, you're not going to be able to treat them anyway. So you're only going to be
correct.
treating at that internal
Right,
wall scenario, aren't you?
right, sir.
So
But
um,
in India, we don't have betting registered. Betting treatment is not available in India.
oh, okay, I was not aware of that. So what's the products that you have for treating
We
active
have
termite?
termit termiticide like imidacloprid, fipronil, chlorpyrifos, bifenthrin. These four products we can use in India.
Okay, so do you have dusts, fipronil dusts?
No, we don't have fipronil dust.
Okay. Are you allowed to use your fipronil or imidacloprids in a foaming solution?
Foaming solution. Okay, sir. That's fine.
Do you have that availability?
Foaming is available in India. Foaming we
Yeah,
can do.
yeah. So at the edges of the marble, for example, where you know
Hmm.
they're coming in and out, is there a way of being able to inject a foaming solution that then goes down and spreads through that soil and fills the soil area or the sand area?
Okay.
So what I'm trying to get at is if they're under the marble floor,
Hmm.
essentially they're not an issue at that point until they exit from under the marble. And so the
Correct.
only way
Right.
they can do that is at the joins
Hmm.
of a wall junction, or if there's cracking in marble. But I suspect there wouldn't be a lot of cracking of the marble, would there?
No, no cracking of the marble. It's
Yeah.
finished, very finished. So
Hmm.
for foaming also we have to drill and inject foam.
Yeah, yeah, and that's for going into wall voids or beneath concrete as such. Yeah.
Yes.
Yeah, yeah. So whilst it may be a little problematic tracking them, and what I do find under areas like that is because it is such a large, broad area, you really
Hmm.
need to have a start point of that activity to be able to track them. So because the field of view is quite small, we might be getting the penetration through the marble as well, but because the tracking area or region of the device itself is relatively small compared to a whole floor
Correct.
of a room, it's like trying to find a needle in a haystack or a needle in a grain of sand. So
Hmm.
we really need a start point of activity that you can see in that scenario, and then from that you're able to track somewhat back from that. Then you may have some more success being able to track underneath the marble.
Okay.
But at the end of the day, to me, it sounds like what we need to do, protect those areas or the gaps at the edges of the marble.
Mhm. Yeah, what we do, requested customer to open the skirting level where the wall and floor junction is there, and we have injected the imidacloprid in that.
Yeah, yeah. So in that sense, that's actually the entrance point to what they're consuming, isn't it?
Mhm.
So if you
Correct.
can get to that, at least you've found technically, even though that may not be the external side of the building, that technically is still an entrance point because there's nothing else that they're actually eating
Mhm.
or being able to damage or consume until they get to that point.
Okay.
So that's sort of the way I would kind of be looking at it from what you're describing the construction that you are faced with. Does
Yes,
that
we
help
have
or
different
make sense?
construction. Yes,
So I hope that makes sense. What I was trying to say there.
yes, I do understand it.
Yeah. Okay. All right. So any other questions? No. Okay. All right. So screen we're on now is online reporting. So you probably noticed on the screen of the Android when you're using a sensor, it has a save log button. So there is the function to be able to save the last 10 seconds of data on which sensor you're using, and that can be uploaded to cloud server. Now you can have, for each company that has a unit or more, that is a free service. So it's another storage area for the data, but enables you then to get on through a web browser to be able to generate supplementary test reports. So if you do find something with the Termitrack, you can have that all on one report. So you can have a business logo, you can add notes and pictures and so forth. So if you do want that sort of function for your company, that's just a matter of reaching out to Termitrack and they can set that up for you. And it is a very simple thing to do. All right, so in conclusion, obviously it's understanding our property, the building we are inspecting. So understanding those construction techniques, where termites can travel, where termites can enter and so forth. What is the conduciveness to termites? What on the property or the immediate surrounds can be considered conducive and be an issue for termites. So it's knowing all of that, knowing where to look in those scenarios, and then possibly using the device, whether moisture, thermal or radar in those areas to try and help you with achieving those results. But we still need to do our regular techniques that we do on a inspection without any other tools. We still need to do certain things as we go along. Having the Termitrack with you though, you have 3 sensors at your disposal, and it makes it very easy then to be able to utilize them as required. Obviously, if you find any areas of concern, utilizing the sensors on the device for further investigation. And also, there is sometimes where you may have to put a hole in the wall as such. Okay, so that concludes our session. So hopefully you have gained some knowledge with it, maybe give you a little bit more information onto where or how to use or even possible treatment uses as well. So before I bid you all a good day, is there any other questions that come to mind?
Next time, any time there is any webinar, can you send me the mails for this so I can pass on to my colleagues and they can join? How today they have joined, lots of people have joined, near about 45-50 people have joined today, so I can pass the mail to my colleagues and they can get the benefit of this webinar session.
Oh, for sure. Yeah, that can be arranged. So when you do get something for the next one, then yes, that can be forwarded on if you like.
Because I got this mail from Mr. Joshua Rao, who was the previous owner of PCI. So I forwarded, as soon as I got the mail, I forwarded to my teammates so they could join in so big numbers.
Yeah. Okay. No, that's no problems at all. So your name will be on the system now. On there. So yeah, look, anything like that we can you can discuss with Termitrack as
Yes.
well. And look, we can put those things into place for you, and obviously the request of a starting time being a little bit later in the morning for yourself and your company, I'm sure we'd be able to accommodate in some way for you.
Yes, sir. Thank you, sir.
Okay, so thank you everyone for taking the time out of your morning to join. Hopefully you have gained something out of it.
Yes.
Please keep an eye out. So there will be links being sent out to everyone that has registered today and joined in. Links will come out for the assessment questionnaire. So it's worth doing that. As I say, there is a recording of this session. So if you would like to obtain a copy of that session, please reach out, and that can be arranged to be sent to you for your internal trainings or briefings as well at your own leisure. So that being
Yes, sir.
said,
We will
thank
require
you.
this. We will require this recording. I will send the mail. And that's thanks. Very beautiful session, and lots of good knowledge we got it from you, sir. Thank you.
Excellent. I'm glad you enjoyed it and glad you got something out of it. Thank you for your kind words. So with that, I'll bid you all a farewell and wish you all have a lovely day.
Thank you.
Thank you very much.
Thank you.
Thank you.
Thank you.